no auto summary. That's why I have defined version here, version 2, then no auto summary, and after that network command. Guys, we can run network command 12.1.1.0 or network 13.1.1.0, or if you want to enable RIP on all active interface with the help of one command, you can run network 0.0.0 command. We can say network 0.0.0. This command will enable RIP routing protocol on all active interface. Okay, so we can enable RIP like this also. We can run 12.1.1.0 or network 13.1.1.0 also exit. Okay, so this is command to configure router number 1. Let me copy this command and let me paste in the console of R1, R1, R2, R3, R4. Okay, I'm going to paste this command here. Now after running this command, how I will verify routing protocol? What is the command to verify routing protocol? So IP protocol. By running this command we can check, and we can check the version as well. It will send update message of version 2. It will receive update message of version 2. Right? On fast Ethernet 0/0, we have enabled the version 2, so it will send and receive the update message of version 2 only. It cannot receive the update or send the update message of version 1. After that, automatic summarization is not in effect because we have disabled the automatic summarization, and the maximum path that it can store in their table is 4. How many path is available? 2. Router 1 have 2 path, right, for the destination 40 network. So maximum 4 path it can install in their routing table by default. We can change this value, right? And here we are performing routing for 12.0.0.0 and 13.0.0.0. But on real devices, if you have disabled the automatic summarization, you will see you are performing routing for 12.1.1.0 and 13.1.1.1.0, right? Not like 12. This is problem of GNS3, guys. Okay, and distance is 120, and we can change distance value as well, and we will change this distance value also in this topology. First of all, let me configure all routers, RIP routing protocol on all routers. So let me configure R2. On R2 fast Ethernet 0/0 IP address is going to be 12.2. On fast Ethernet 1/0 IP address is going to be 24.1.1.2, and router RIP version 2, no auto summary, and network 12.1.1.0, and which network? 24 network. Correct? So let me copy this configuration and let me paste this command in the console of R2. Here I am going to paste this command. Fine. Then router 3. So on router 3, fast Ethernet 0/0 IP address is going to be 13.1.1.3. On fast Ethernet 1/0 IP address is going to be 34.1.1.3, and router RIP version 2, no auto summary, and network 13.1.1.0 and network 34.1.1.0. Let me copy this command and let me paste it in the console of R3. Fine. Then finally router 4. Router 4 fast Ethernet 0/0 will have what IP address? 24.1.1.4, and fast Ethernet 1/0 34.1.1.4. And then we have some loopback as well here. So interface loopback 1, I'm going to say IP address 40.1.1.1 255.255.255.0. We have 3 loopback, so let me copy this and let me paste it here. 2 3 loopback interface loopback 2 IP address is 40.1.2.1, loopback 3 IP address is 40.1.3.1. Fine. Then network. Here I can run network 0.0.0 command also, or I can run 24 network 24.1.1.0, 24.1.1.0, then 34 network, then network 40.1.0.0. This command will also enable reporting protocol on all loopback interface. Getting my point, guys? When I am running network command, see how it's working. Let's say on router 1 we have one loopback 192.168.1.0. Correct? I am running network command, network 192.168.1.0. See, router 1 will check that this network is running on which interface. This network is running on which interface. So it will enable reporting protocol on that interface. Now let's say here I have one more loopback 192.168.1.128, right, /25 and this is also /25. Both are different network, right? Now router will check this network is running on which interface. So this time this network is matching two interface, yes or no? This time this network is matching two interface, loopback 1, loopback 2. So it will enable reporting protocol on both interface. So like this, here I am running network 40.1.0.0. So this network command will match all these three loopback interface. So it will enable reporting protocol on all these loopback interface. Got it? So here I am saying 40.1.0.0. Let me copy the configuration commands and let me paste in the console of R4. Done. What happened? Network 40.1.0.0. And now I am going to verify R1 that R1 have received 40 network or not. So on router number 1, I am going to check so IP route rip. So yes, you can see router 1 have received all 40 prefixes via 2 path, and this time router 1 is performing load balancing. Why? Because from both sides you can see distance is same and metric is same. Metric is also same and distance value is also same, so it will perform load balancing. It is performing load balancing. And now if you will check connectivity, ping 40.1.1.1, you can see ping is working. For all network it can ping. Router 1 can ping the user from these all network. 2.1, yes, ping is working. 3.1, ping is working. Now this time here on router number 1, I don't want that it should perform load balancing. How I can achieve it? Let's say I want that router 1 should forward traffic in 40s network, like in these three network, via router number 2 only, not via router number 3. How can I achieve this? First of all, see here in the router rip, we can configure maximum path. I'm saying please install maximum one path only in there in your routing table. So now it will install only one path in their routing table. So IP route rip. So IP route rip. Wait for some time. Now you can see all networks are reachable via router number 2. Maybe it will install all path via router number 3 or via router number 2, right?
So how it is selected, sir?
No,
it is
it's random.
taken,
First it have received update message from router number 2. That's why it have installed all paths via router number 2. Let's say here, if I will down this interface fast ethernet 0/0 shutdown and then no shutdown, and so IP route rip. This time it have installed all path via router number 3. Okay.
Okay, but our requirement is suppose it should go via R3 only, not via R2.
Yeah,
So
yeah,
in
that
that
also we are going to understand. So this is the first way, like how we can configure maximum path. That router should install how many path maximum in their routing table, right? And what maximum value you can configure here, router rip and maximum path question mark. You can see you can configure up to 32 paths. So router can install up to 32 paths in their routing table. Here again I am going to set 2. It will again install both. So IP route rip. Wait for some time, it will install both paths. Again it will start performing load balancing. When it will receive update message from router number 2, it will install that path also, upper path also. Correct? It have now installed both path and it is performing load balancing. Now guys, as I told you that by default distance value is 120 in RIP. Now if I will configure distance via router number 2 is 100, what will happen? Now this time router 1 is receiving these prefixes via router number 2 with distance 100, and here it is receiving same prefix with distance 120. Now which one is best? Via which path it is receiving best prefixes?
Lowest AD value.
Lowest AD value via R2.
Yes.
So we can manipulate the distance value for path manipulation. Here on router number 1 we can say router rip and then distance. Distance, let's say I am going to set 100 and then source IP address. Whenever you will receive any update message from which source, when router 2 will advertise prefix 40 prefixes to router number 1, what will be the source in the update message? Source will be 12.1.1.2 IP address of exit interface, IP address of fast ethernet 0/0 of router 2. Yes or no? So here I am saying whenever you will receive update message from this source means from router number 2, set the distance value at 100. And now source is this one, wildcard mask of source, let's say this one. Fine. Wildcard mask also we need to mention here. And now if I will check routing table, so IP route rip, you can see distance value is what? 100. Because of that it have installed all path via router number 2. But if upper path, let's say fast ethernet 0/0 will goes down, interface fast ethernet 0/0 will goes down, shut down. And now again if you will check routing table, so IP route rip, wait, it will receive update message after 30 seconds from router number 3. Correct? AD value is what? 120. So it is router 1 is receiving update message from both neighbor, from router 2 also, from router number 3 also. From router number 2 it was receiving same prefixes with least AD value. Okay, so because of that, when again this interface fast ethernet 0/0 will come up, it will receive same update message, same network information with least AD value, so it will install the prefixes via router number 2. And now you can see because of distance value from both sides, let's say you want to change distance value from both sides, I want to set distance value same 100. I don't want the distance value should be 120, so we can do that also, router rip and then distance 100. That's it. Don't define here source. Now we have set AD value 100 from both sides, from the all neighbor, for all neighbor. We have not defined any specific source here. So again router 1 will start performing load balancing for 40 networks. Done. Any question till here? Okay, you can see it is performing load balancing.
So by default, it will do the load balancing based on the hop count is same. That's why, right?
Right.
And then accordingly, we can do the manipulation, path manipulation.
Yeah.
Okay, fine. Thank you so much.
Okay. Is it clear to all? And how I will check how many command I have run in RIP protocol. So run section router RIP. This command will show me how many command I have run in RIP routing protocol. So you can see router RIP version 2, network 12, network 13, maximum path 2, distance 100 from this source and no auto summary. I have run these all command on router number 1. I'm going to remove this command here. Say no router first RIP and then no to this command. I am going to remove this command first. Then no distance and then no this command also maximum path 2. By default maximum path is what? By default maximum path is what? So IP protocol. Got it? Any confusion guys till here? Now if you want to see that this router is sending update message from how many interfaces, so we can debug. We have one feature of debug. We can debug RIP routing protocol, debug IP RIP. Now it will generate log message when router 1 will generate any update message. Whenever router 1 will generate any update message, it will show you one log. So you can see receive RIP receive version 2 update from 12.1.1.2 on fast ethernet 0/0, means it have received one update message from 12.1.1.2 on fast ethernet 0/0. RIP sending version 2 update to this address 224.0.0.9 via fast ethernet 1/0. Correct? So it is sending update message from these two interface, fast ethernet 0/0 and fast ethernet 1/0. I'm going to disable the debugging, say no on all. And on router number 4, I am going to enable debugging, debug IP RIP. Here you can see router 4 is sending update message from their all loopback interfaces also. From their loopback interfaces also it will send update message. Are you able to see RIP ignore version 2 packet from 40.1.1.1, and here there was one message. Actually what I am trying to explain guys here, that let's say router 1 is connected with one LAN. Here we have one LAN switch, and then we have some PCs here, and this interface is connected with router number 1. On this interface also we have enabled RIP. So router will send RIP from this interface also after every 30 seconds. But here RIP update is not required. Right? What PC will do with RIP update or switch will do with RIP update? We are not running RIP here, but still switch is sending update, router is sending update message from their LAN interface after every 30 seconds. So to disable the RIP update message or any message of RIP routing protocol on LAN interface, you can configure that interface as passive interface. We can tell to router 1 that this LAN interface is passive interface, then router will stop sending update message from this interface. Okay, so always keep in mind that router never send update message from passive interface. So like on router number 4 we have 3 loopback, so router 4 should not send update message from loopback interface. Because of that we should configure loopback interface as passive interface. How? Router RIP and then passive interface loopback 1, passive interface loopback 2, passive interface loopback 3. Now router 4 will not send any update message from these loopback interfaces. And in show IP protocol, we can check the passive interface. Like passive interfaces are these three interfaces. Got it? Clear? Now, each routers are sending update message after every 30 seconds to their neighbor. Now I want to increase this timer. I don't want that router should send update message after 30 seconds. I want that router should send update message after 100 seconds or 200 seconds. So we can change that also. Like on router number 1, let's say I want to change the timer. By default timer is show IP protocol. Here you can see the timer. Update timer is 30 seconds. Invalid timer is 180 seconds. Hold on timer is 180 seconds. Flush time is 240 seconds. In last class we discussed this timer also. And today we are going to change this timer. Config T, router, rip, and then timer basic. And after that, if you will put question mark, you can see it's asking for update time. What should be the update time? Let's say update time should be 100. Then what should be the invalid time? Let's say invalid time should be 500 or 200 seconds. Then hold on time, let's say hold on time should be also 200 seconds. That means if prefix is invalid, you will flush the prefix. So flush time should be also what? 200 seconds. Enter. And now here if you will run command show IP protocol, you can see now this timer. Now update timer is 100 seconds, right? It will send hello message after 100 seconds. Now hold on time, invalid time is 200 seconds. Hold on time is 200 seconds. Flush time is 200 seconds, right? But still router 2 and router 3 and router 4 are sending their update message after 30 seconds. So on all routers we need to change these timers. What will happen if I will configure, let's say hello timer 100 seconds and hold on time 50 seconds? Let's say on router number 2 I am going to configure hello timer, router, rip, and timer basic. I'm going to say update time is 100 seconds and hold on time is invalid time, let's say 50 seconds. Hold on time is 50 seconds and flush time is 50 seconds. What will happen now on router number 2? Router 2 will send update message to router number 1, right? It will send update message to router number 1. Router 1 will hold that information for 50 seconds and it will send next update message after 100 seconds. That means for 50 seconds router 1 will not have these prefixes. Got it? So always keep in mind hello time should be lesser than hold on time. Means update time, sorry, I'm saying hello time. Update time should be lesser than hold on time. Hold on timer should be greater than update time. Correct? Clear, guys? Now let's say this router 1 is connected with internet. Router 1 is connected with internet router here. Internet. So what you will do on router number 1, you will configure one default route. Yes or no? On router 1 you will configure one default route towards ISP, right? So let me configure here one default route on router number 1. On router number 1 I will configure one default route, IP route 0.0.0, 0.0.0, and next hop IP address is, let's say, between router 1 and router 2. ISP router, let me configure one IP as well. Interface fast Ethernet 1/0, no shut, and IP address is 1.1.1, 255.255.255.0. Done. Now I am going to say IP route 0.0.0, 0.0.0, and exit interface is fast Ethernet 1/0, let's say. So we have one default route on router number 1 towards ISP, correct? Now on each router, like on router number 2 also, router number 3, router number 4, on all router we need to configure one default route towards router number 1, so that these LAN user can forward traffic to internet. So let's say we have 50 number of routers connected with router number 1 here. So on all routers you don't need to configure default route. Directly here on router number 1 we have one default route. We can propagate that default route in RIP routing protocol, and router 1 is sending the RIP update message to their neighbor. So router 1 will start carrying default route in their update message. So router 2, router 3, and router 4 will learn default route via RIP routing protocol. How? On router number 1, see, show IP route RIP. This is routing table of RIP, correct? And show IP route. This is global routing table. In global routing table, we have one default route towards ISP. Now I want to propagate or redistribute this default route in RIP routing protocol, so that router 2, router 3, and router 4 should also receive this default route. So I am going to say router RIP here, and default information originate. Default information originate. It will start originating one default route in RIP routing protocol. So on router number 2, now you can verify on router number 2, so IP route RIP. So through RIP routing protocol, it have received one default route via 12.1.1.1, right? Via 12.1.1.1. And router 4 also, on router number 4 also you can check, so IP route RIP. So through RIP routing protocol, it have received one default route. It is performing again load balancing, because router 2 and router 3, both router are advertising same default route. Got it?
So this is only for default route, or even if we have some static routes, those will
That
be
is redistribution. Okay, let me add some router here. Let's say router 3 or router 2 is connected with some other router. Router 2 is connected with one more router here, R6, and on router number 6 we have some, on router number 6 we have some loopbacks like 60.1.1.0, 60.1.2.0, 60.1.3.0, 3.0/24/24/24, right? And on router number 2 we have configured a static route for this network. On router number 2, let me show you. On router number 2, on router number 6, first let me create this loopback here. Config T, interface fast Ethernet 0/0, no shut, IP address. Between router 2 and router 6 I am using 26 network, 26.1.1.6, 255.255.255.0. exit interface loopback 1, IP address 60.1.1.1, 255.255.255.0, 255.255.0. interface loopback 2, IP address is 60.1.2.1, 2.1. interface loopback 3, IP address is 60.1.3.1, 3.1. Here I have created some loopbacks, so IP interface brief exclude unassign. You can see we have 3 loopback on router number 6, and this is the IP address on fast Ethernet 0/0. Let me take you to R2 now. On R2, first I am going to configure IP on fast Ethernet 1/0, which is connected with router number 6. Fast Ethernet 1/0, no shut, and IP address 26.1.1.2, 255.255.255.0. And now I am going to configure a static route. IP route and 60.1.1.0, 255.255.255.0, and exit interface is fast Ethernet 1/0. Then same for 60.1.2.0 and 60.1.3.0, right? Here we can check static route. So IP route static. So you can see we have 3 static route here. And in the RIP routing protocol, so IP route RIP. These are RIP routing protocol. Now I want to, advertise the static route prefixes in RIP, so that router 1, router 4 and router 3 should also get these 60 prefixes. So what I can do on router number 2, I can redistribute, because RIP is maintaining a separate their table. In that table there is prefixes of RIP only, and router have one separate static route table. There they have 3 prefixes like 60.1.1.0 to 60.1.3.0, like both are separated on router number 2. Now we are going to inject a static route prefix in RIP. Okay, so how we will inject it? Router RIP, and then redistribute static. That's it. Redistribute static. And after that, if you want to define metric, like here on router number 2 we are advertising some prefixes of a static route in RIP, so we can tell to router number 2, you should advertise it with metric, let's say 5, means hop count 5 or hop count 1 or hop count anything we can configure here. By default we have not configured any metric here. So see, on router number 1, so IP route RIP, so IP route RIP. So it have received 60 prefixes. Yes, it have received 60 prefixes via router number 2, and hop count is 1. Hop count is 1. And on router number 2, this time I am going to say metric 5. So now on router number 6, metric will become what? 6, 5. So if we are not defining any metric, any hop count, it is advertising a static route with 1, metric 1, and manually we can set also. And on any other router also, on router number 3, so IP route RIP, you can see it have also received 60 prefixes, 60.1.1.0, 60.1.2.0, 60.1.3.0, and router number 4 have also received these 60 prefixes. So IP route RIP, 60 prefixes, right? And let's say on router number 6 I have configure, I am going to configure one default route here, because we are not running RIP between router 2 and router 6. So router 2 is not going to advertise any prefix of RIP to router number 6. So manually I am going to configure one default route here. Default route 0.0.0 exit interface fast Ethernet 0/0. And now from router number 1, let me check connectivity. Ping 60.1.1.1. Will ping work? Ping is not working. May I know the reason why ping is not working? Why ping is not working? See, router 1 will check their routing table. So IP route. In their routing table, one route is available for 60 prefixes via router number 2. It will forward traffic to router number 2. Router 2 will check what? Their routing table. So IP route. In their routing table also, one route is available for this network. It will forward the traffic to router number 6, means from fast Ethernet 1/0. On router number 2, this network is directly connected. Okay, it will forward the traffic to router number 6. And when router 6 will receive the traffic, it will check the routing table. What will be the source in ICMP packet, guys? When router 1 will generate ICMP packet for 60.1.1.1, what will be the source there? Source should be
interface IP.
Exit interface IP means 12.1.1.1.
Yes.
And here we don't have any route for 12 network, but we have one default route towards router number 2. So router 6 will forward traffic to router number 2, and router 2 should forward it to router number 1. So ping should work, but ping is not working. Yes, Prem. Ping is working from router number 1 also, from router number 2 also, from router number 3 also. We can say ping 60.1.1.1. Ping is working, and from router number 4 also ping 60.1.1.1. Okay, wait. Access control list. What is access control list? Anyone want to explain what is ACL?
ACL like access control list, like which traffic we want to allow and which we can deny through that.
Good.
It's more
Anything
like
else?
no, adding the rules in the firewall similarly, but it will be stateless packet inspection, right?
Correct. Good. Anything else?
It's
Access
basically
control. Yes, Prem.
it is basically used to filter the routes, the traffic.
Wow, you are correct. How many types of access control list we have?
There are two types,
So
numbered. Sorry,
standard
standard.
and extended.
So in standard
Yes.
also we have two category like name and like numbered, and the same is for extended as well.
Okay. Now, what is difference between a standard and extended?
The range is different, like 0 to 1 to 100. It is like standard, and
Only network difference, range difference is there, or something else? Like in extended, we can block the network, but in extended ACL, we can
like in extended we can block the based on the feature wise as well.
services as well.
Yeah, services as well.
Yeah. So access control list is a set of rule which will allow or deny a specific traffic moving through the router. Access control list is set of rule. We will define the rule on router. According to that rule, router will take decision that I should forward the traffic or I should deny the traffic. Before checking routing table, now router is doing what? To forward the traffic. Router is checking routing table. Router is checking routing table. Like if from router number 4 I am pinging 60.1.1.1.1. Once I will hit enter, router 4 will check their routing table. So IP route, is there route available for 60 network? Yes, it will say route is available and exit interface for this network is fast ethernet 0/0. And when router will forward the traffic from fast ethernet 0/0, so we will apply access control list on interface. Let's say one access control list is applied on fast ethernet 0/0, then router will check that access control list first, and according to that it will take forwarding decision. If traffic is not allowed, it will deny the traffic. If traffic is allowed, then only it will forward it to router number 2 or from this interface. So before checking routing table, you can say router is going to check access control list entry. Fine. Then ACL is used for filtering traffic based on given filtering criteria on the router interface. It is an layer 3 security which control the flow of traffic from one router to another router. It is also called packet filtering firewall. And there are two types of access control list, numbered and name, and both are categorized into two part. Again, number is also categorized in two part and named ACL is also categorized in two part. Okay, so both ACL are categorized into two part, standard and extended. Standard and extended. Whatever rule we will define, we will configure on the router, that rule will identify by number or name. That will define which ACL we have created. If rule is defined by a number, that means we have configured numbered ACL. If rule will identified by name, that means we have configured named ACL. Okay. Now the difference between standard ACL and extended ACL. Standard ACL range is 1 to 99 and extended ACL range is 100 to 99. with the help of extended ACL, we can block the network, we can block the host, we can block the subnet. Entire network. Subnet means subnetted network, means after subnetting. So we can block subnetted network, we can block the entire network, we can block the host. But with the help of extended ACL, we can block the network, we can block the host, we can block the services as well, right? Like if you want to deny only HTTP traffic, so that is not possible by extended ACL, because with the help of extended ACL we cannot define the service, because now you are allowing the REST service. If you will apply extended ACL, all communication will blocked. If by using extended ACL you will block HTTP traffic, so ping will also blocked, REST traffic will also blocked automatically. And extended ACL should be implemented near to the destination, closest to the destination, and extended ACL should be applied closest to the source. And here in extended ACL, filtering will done on the basis of source IP base. Router will check only source. On the basis of source only it will take decision. The traffic is allow or deny. But in extended ACL, filtering is done on the basis of source IP, destination IP, protocol, and port number. Routers are going to check this all information.
Sir, can you explain a bit about that implemented closest to the destination? Or yes.
Okay, brother, let's say I have this network here, and this router is connected with one switch, and here we have some users. Let's say this is network 10.1.1.0/24. Now what you want, that 10 users should not communicate with 60 user. And here we have one network 20.1.1.0, 20.1.1.0, 20.1.1.0/24. Correct? Now as I told you, in extended ACL, filtering will take place with the help of source IP address. So if I will apply access control list on router number 1, what is my requirement? My statement is 10 networks should not communicate with 60 network. So if I will apply access control list on router number 1, 10 network cannot communicate with 20 network also. Why? Because filtering will based on the basis of source IP. It will check only 10 network is deny, that means deny the traffic. It is not going to check destination. So we should apply this ACL on router number 2 on this interface, so that whenever router 2 will forward the traffic from this interface, it will perform filtering on the basis of source address. That if source is 10 network, let me deny the traffic. Getting my point?
Yeah, okay, sir. Yeah.
This ACL
Right.
will work on the egress interface only then. It will not.
No, in both interface,
So in this
in ingress or outgress.
in this scenario,
In
right,
all-
in R2, if the packet it is received on F0/0,
Okay, here
yeah.
on router number 2.
So we have an filter ACL saying deny traffic from 10.1.
Here I will tell to router number 2 that whenever you will out the traffic from this interface, and if source is 10 network, from this network you should deny the traffic. If I will apply the ACL on this interface, I will tell to router when traffic will in on this interface, please check the source. If source is 10, deny the traffic.
Okay, so both in and out this will work.
Yeah, we can apply 2 access control list on one interface.
Okay,
One in direction and one in out direction.
okay.
Okay, but let's say here I have on this interface in direction I have applied the ACL that 10 should not be permitted for 20 network. So when 10 network want to communicate with 20 network, it will check only source, so it will deny the traffic. It don't, standard ACL never check the destination. So that's why we are saying it should be implemented closest to the destination. And when we are applying the extended ACL, so if you want to filter the communication between 10 to 16, then why you will use this link bandwidth? It is better to drop the traffic on router number 1. So you should apply extended ACL nearest to the source, because extended ACL is going to check both source and destination. So that's why we are saying it should be implemented nearest to the source, because here if you will apply extended ACL on router number 2, that is also fine, no problem, but router 2 will drop the traffic, but it is better if router 1 will drop the traffic. We will not use this link also, correct?
Yes, yes.
So for route filtering, we can use access control list here. This is, till now we discuss access control list for packet filtering. Now tell me the other use of access control list is for classification of traffic, to identify the traffic, to make a traffic as an interesting traffic. Like I want to filter this network 40.1.1.0 on router number 1, because router 1 never need to forward traffic in 40 network, 40.1.1.0 network. Router need to forward traffic in lower 2 network but not in the upper network. There is no user connected with router number 1 who is going to communicate with 40.1.1.0 network. So on router number 1, why router 1 will keep this network information in their routing table unnecessary? So we need to filter this network on router number 1. So here on router number 1, we have to classify the traffic, that which traffic I want to filter. So here also we are using access control list for the classification of traffic. So like on router number 1, what we can do, I can make this traffic, this network 40.1.1.1 as a interesting by creating one access control list. I can say access list 10 and permit 10.1.1.0, wildcard mask 0.0.255. That's it. Now if you will check access control list, do so access list. We have one access control list here. Access list number is 10. This is sequence number. We will discuss more about access control list, guys, later. Okay, like this is sequence number. Here we can define the sequence number. If we will not define sequence number, it will take 10 and there is increment of 10. If I will create other access control list without defining the sequence number, so it will increment sequence number by 10. Okay, and now I have permit this traffic 10.1.1.0/24 wildcard mask, this one, right? So this wildcard mask is matching this network only, not 10.1.2.0 or 10.1.3.0. In the same way, here I am going to say no access list 10, and this time I am going to create access control list access list 10, and I am going to say deny 10.1.1.0 wildcard mask 0.0.255. See, by creating access control list on router, nothing is going to happen, right? Router is not going to filter any prefix. See the routing table, do so IP route RIP. In the RIP routing protocol, we have this network 40 network, right? But until and unless I will not apply this access control list, it will not work. So this time I am going to apply this access control list in RIP routing protocol, not on the interface. So here I will say router RIP, and here we have one feature for the route filtering, that is distribute list. And then you can see you can call to your access control list. You can call to your access control list here. So I am calling which access control list? Number 10. In number 10, I have denied which network? 40.1.1.0, right? I have created one access control list. In that access list, I have denied 40 network, and here in router RIP distribute list, I am calling the access control list 10. And then in which direction you want to apply it? In direction. That's it. Now if you will check routing table, so IP route RIP. So IP route RIP. Wait for some time. After some time, you will see this prefix will be filtered over here. This prefix will be filtered over here.
Just
After hold on time. Yes.
Just for clarity, so access control list is used for packet filtering and for route filtering. Is that correct?
For the classification of traffic, yes. For route filtering, we have used redistribute list, right?
Yeah.
Here, like access control list, we can use prefix list also, route map also. There are multiple options we have.
Okay.
Access control list, here I have used access control list for the classification of traffic, for to classify the traffic, to identify the traffic, that which traffic you want to deny.
Okay.
Right, to deny the traffic I have used distribute list.
Okay.
What hold on time I have configured on router 2 and router 3? Sorry, update time. I think update time on router number 2 is 100 second. Router rip and timer basic 30 second. Update time 30 second, 100 second, 100 second, 100 second. Why router 1 is not receiving update? See what is happening, can anyone explain? See, when you are denying one traffic, by default all rest traffic will deny, so you have to run one more statement in access control list. If I am denying one traffic, there is implicit deny, means all other traffic will deny, so we have to permit rest traffic. So in access control list I am going to say you have deny 40 network, access control list 10, permit IP any. I am going to say permit rest traffic, permit rest all traffic, and now so IP route rip. Wait for some time, this time it will receive the update message. So access list, yeah, we have to match, and 8 entry is also there, so IP route. You can see 40.1.1.0 network is still there. From which path? From router number 2. 40.1. So access list 10.1.1.0 wildcard mask is correct, permit any correct. So IP protocol, here in show IP protocol we can check the filtering. You can see for incoming traffic, incoming update filter for list all interface is 10, and in access control list 10 we have deny 40.1.1.0. Oh, I have denied 10.1.1.0. Here it should be 40.1.1.0. So let me do one thing. Here I am going to remove access control list 10, and again I am going to create access control list 10 deny 40.1.1.0 wildcard mask 0.0.255 and access list 10 number 10 permit any. And now let me show you the routing table. So IP route rip, soon it will filter 40.1.1.0 network. We can do one thing, we can set the interface once, and we can say no set interface f1/0 shutdown and no set. So IP route rip, you can see 40.1.1.0/24 network is filtered. This time I have only these two network. So in EIGRP and in OSPF, we are going to discuss advanced route filtering also. We will use route map, prefix list, right? This is very basic, like we are not using RIP routing protocol nowadays, and interviewer is also not going to ask, more question. Maybe they can ask you hardly 1 to 2 question from RIP. So that's why we will not discuss more about the route filtering in RIP. But in EIGRP and OSPF, route filtering is very important, because if you know the route filtering, that means you have control on traffic flow, right? With the help of this, we can manipulate the path also. We can filter the prefix from a specific source also, that from a particular source I want to filter 40.1.1.0 network. Okay, let's say here I want to filter all 60 prefixes. What I will do, I want to filter all 60 prefixes. Or let's say router 1 is advertising one default route, right, to router 2, 3, 4. So I want to filter that default route. What I will do, to filter default route, simply we need to remove the command. But let's say I want to filter, let's say my requirement is, what I want, router 2 should not advertise 60 prefix to router number 1 or to router number 4 or router number 3. Or my requirement is, let's say this time from here I am going to remove the filtering from router number 1. Do so run section router RIP. I'm going to say no to this command. Distribute list 10 direction in. No distribute list 10 direction in. Router RIP. Done. Now show IP route RIP. It will receive 40.1.1 network also. Yes, it have received from router number 3. It will receive from router 2 also. And this time, let's say I want that router 3 should not advertise any 40 prefix to router number 1. Router 3 should not advertise any prefix to router number 1. How I will configure the distribute list? Now you can see router 1 have received again all 40 prefixes from both neighbor, and this time I don't want to advertise 40 prefix from router number 3. What I will do, first I will create one access control list number, let's say 10, deny 40.1. let's say 0.0.0.255, right? In this entry all prefix will match, correct? And then access list and deny 40.1.0.0, access list and deny 40.1.
Exit interface we can
0.0.0.0.0.255 wildcard mask was incorrect.
No.
Access list 10 permit any, right? Rest traffic is permitted. Now router RIP and distribute list number, access control list number 10, and in which direction? In odd direction. This time I am going to apply this filtering in odd direction, means when router 3 will odd these 40 prefixes to router number 1, it will filter the update, right? Enter. And now on router number 1, if you will check again routing table, so IP route RIP, wait for some time. After some time you will see router 1 is receiving these prefixes, these 40 prefixes from router number 2 only. I've configured everything.
Sir, I guess the subnetting is not, I mean, the wildcard is not given correctly in the ACL in R3.
Oh, Yeah. Wildcard will should be 0.255.255, right?
Yeah.
So again on router number 3, I can say no access list 10 and access list 10 deny 40.1.0.0.0.255.255 access list 10 permit any. Correct?
Yeah, correct, sir.
Okay.
Redistribute.
We have already run redistribute command, distribute list command. Na?
Yeah.
So IP protocol. You can see filtering is applied for all direction. Clear IP route rip. Rip is very slow in convergence. Now you can see it is receiving 40 prefix from router number 2 only, not from router number 3. Got it, guys? Is it clear? Now you guys also need to perform lab. If only I will configure, on the router or these things, your concept is not going to be cleared. So you have to also configure whatever lab I have shared. First configure that one, then you should configure these things like path manipulation. And we have one more option here. Let me check router rip IP summary. Okay, I think that is in EIGRP. Yeah. Automatic summarization is not possible in RIP, I think. That is possible in EIGRP. So EIGRP is good routing protocol we are using as well, and interviewer also ask some question, and in CCNA exam paper also you will see some question from EIGRP protocol, right? So tomorrow we will start EIGRP, guys. Means tomorrow means Monday. You have 2 days. Please perform these lab of RIP before it, so that you can understand EIGRP.